In this tutorial, we'll analyze the stress in a pressure vessel by using axisymmetric elements. So we'll begin by selecting the Empty Project icon after starting the program. We will now select Browse, and then locate the Parasolid file, Pressure Vessel. On the project page, we'll now expand the Advanced Geometry Defaults, and then set the analysis type to 2D, followed by clicking on New Simulation. We'll now select the Units option and make sure that the units are set to metric millimeters. The pressure vessel is made of steel, so we'll confirm that the material is defined to be structural steel. We'll now click on Geometry in the Outline window, and then in the Details window, set the 2D behavior parameter to axisymmetric. We need to add a coordinate system, so we'll select Model in the Outline window, and then click on Coordinate Systems in the toolbar. Next, we'll insert a symmetry boundary condition by selecting Model in the Outline window, and then click on Symmetry in the toolbar, followed by clicking on Symmetry Region. The selection filter is now set to Edge, which allows us to select the bottom edge of the model. In the Details window, we'll now click on No Selection, followed by clicking on Apply. And then, to define the normal direction, we'll change the Symmetry Normal parameter to be the y-axis. The new analysis type is next defined to be Static Structural. The next step is to define the internal pressure acting on the inner edges of the pressure vessel. However, before we do this, we'll change the view to Wireframe. We'll now make sure that the selection filter is set to Edge, and then select the inside edges of the pressure vessel. In order to define the load, we'll select the Static Structural folder, and then click on Loads, and then Pressure. In the Details window, we'll now enter 100 for the magnitude of the pressure. In order to request results, we'll first select the Solution folder, and then click on Deformation and Total. Then we'll click on Stress and Normal, and set the orientation to Z-axis in the Details window in order to define the hoop stress. In order to request longitudinal stresses, we'll again click on Stress and Normal, and then change the orientation to Y-axis in the Details window. We'll now click on Solve. We'll first examine the hoop stress by clicking on the first Normal Stress in the Outline window, and then zoom in on the inside corner and use the Probe tool to display the stress value. As we can see, the finite element model has calculated a hoop stress of 342.3 megapascals, which compares very closely to the hand-calculated value of 343.2 megapascals. We'll now examine the longitudinal stress by clicking on the second Normal Stress, and again use the Probe tool to display the stress value. The stress calculated by the finite element model is 121.6 megapascals, which is the same as our hand calculation.